Hello बच्चों, let's read this question. A particular hydrogen-like atom has its ground state binding energy 122.4 electron volt. It is in ground state. Then we have to find which of the following options are correct. So students, इस question में हमें बोला गया that let's say this is a hydrogen type hydrogen type atom in which this electron's binding energy is given by 122.4 इलेक्ट्रॉन वोल्ट और ये ग्राउंड स्टेट में यानी n इक्वल्स टू 1 एनर्जी लेवल पर है। देन हमें बताना है इनमें से कौन सा ऑप्शन करेक्ट है। फॉर दैट प्लीज नोट द की कॉन्सेप्ट ऑफ दिस क्वेश्चन which says energy associated with each energy level is minus 13.6 z square upon n square, and when electron absorbs energy which is exactly equal to the difference in energy level of final and initial cells, then electron jumps to final to that final energy level, and this difference in energy can be written as minus 13.6 into z square upon, let's say it jumped to final state, and f square minus 13.6 z square upon n final square. So students, यहाँ से हम लिख सकते हैं minus 13.6 z square is common, 1 upon n final square minus 1 upon n initial square. So students, this is the value of del E. Mentioned that this atom has binding energy 122 electron volt. So what is meant by binding energy? The binding energy means that this electron gets enough energy so that it gets extracted out from the influence of the nucleus of that atom. That is, let's say if this atom was present in ground state, then after receiving binding energy, it will reach to n equals to infinity. At n equals to infinity, this electron will not experience any force from this nucleus. So n final will be infinity. In this case, we can write delta E as 122.4 electron volt. This must be equal to minus 13.6 into n final is infinity square minus 1 upon initial square, that is 1 square, and this is z square. So students, 122.4, this is 120. This must be equal to minus 13.6 into this term will be 0, and this is minus 1 upon 1 square will be 1 into z square. So 122.4, this is equal to 13.6 z square. From here z square is, this is equal to 9, and z will come out to be 3. This shows that atomic number of this atom is 3. So option A is correct. Let's check option B, C. An electron of 90 electron volt can excite it. So students, let's check if an electron of, this is a nucleus, an electron can excite this revolving electron to higher orbits or not. For that, let's check the minimum case, that if this electron has sufficient energy to transfer this electron to even second energy level or not. For that, n final will be 2. So del E equals to minus 13.6, and z we have calculated 3. So this will be 3 square is 9, and 1 upon n final square. So 2 square minus 1 upon 1 square, where 1 is initial ground state energy level. This is minus 13.6 into 9 into 1 upon 4 minus 1 upon 1 is 1. So this is minus 13.6 into 9 into minus 3.4. On calculating the energy, value of delta I will come out to be 91.8 electron volt. But this electron was carrying energy equivalent to 90 electron volt. Clearly, it lacks that amount of energy which this electron requires. So no transition will take place. Now, no transition, hence no excitation. Let's check option C. Option C says an electron of kinetic energy nearly equals to 91.8 electron volt can be brought to almost rest by this atom. So students, from the last option we have seen that electron requires an energy of 91.8 electron volt to transit from first energy level to second energy level, and also this electron is carrying that much amount of complete transfer of energy. This electron's energy will be kinetic energy will be zero. This is because it has transferred its complete kinetic energy to this electron. So we can write half mv square equals to 0. From here v equals to 0. So we can say that yes, this electron can be brought out to rest if it completely transfer its energy to this electron. So option C is also correct. Let's check option D. This says an electron of kinetic energy 2.6 electron volt may emerge from the atom when electron of kinetic energy 125 electron volt collides with this atom. So students, what happens actually happens when this electron gets, let's say this was the electron with energy 125 electron volt. This electron requires the energy only equals to the required energy was equal to 122.4 electron volt. So this will absorb only this amount of energy, and the rest energy will be carried by the striking electron. Rest energy is carried, or this will remain with striking electron. 125 minus 122.4 electron volt, and this is equal to 2.6 electron volt. So this electron, this will come out of the atom with energy 2.6 electron volt. So option D is also correct. So the correct options which we got in this question was option A, option option C, and option D. So the correct set of answers of this question is A, C and D. I hope आपको ये concept समझ आया students. Thank you.